So here's another mechanism practice problem. All we're given is just some acid, and we have to somehow get what's on left to what's on right. So give it a try, and we'll work through it in just a second. So there's a lot to write down in this problem, so it's easy to uh, miss bonds or a methyl group, but we'll try to go slow. First possible thing, I'm going to protonate my alcohol. Easiest thing to protonate because it's got that lone pair of electrons, and this takes care of our highest energy thing. So what that makes will be down here. Okay, so here I have the molecule drawn. Now at this point, I'm recognizing I have water that's attached to a carbon, giving it that positive charge, and it wants to leave. Well, luckily it's on a tertiary carbon, and that tertiary carbon also has some resonance that can be played with this double bond to the right of it. So doing general heterolysis right here is not a bad idea. So let's go ahead and suggest this, just like that, and draw what our product is over here on the right. Okay, so I've redrawn the molecule. We're left with this positive charge on that tertiary carbon, like we said we would have, because we did heterolysis. I guess I could also, for the sake of this, I could say plus H2O, because we know we kicked out some water. So at this point, we can do two different things. We can either say that the water initiates some bond movement, or we can say bond movement happens and then water comes and satisfies a charge. For the sake of space, I'm going to go ahead and say that water is going to be the thing that starts the bond movement. So it might be easiest to actually maybe start in the middle. So I'm going to pick this ring right here. It's 6 carbons, so I'm going to find 6 carbons from this double bond. So 1, 2, 3, 4, 5, and there's your 6th. So that's how I'm going to move my bonds. And so if I move that bond like I did right here, then this bond has to move through like that to give another 6 carbon ring. If you're counting, those are now we have 1 5 carbon ring and 2 6 carbon rings at the end of this. I should also say real quick before I go forward, when you do this first arrow that I have here, that's what's going to satisfy that charge. So this is kind of working backwards. Now at this point, we want to let this triple bond make a bond at that end of the double bond. So, and then again, I was saying you can either do it like I've shown right here, or you can show that oxygen initiates it. I'm showing oxygen initiate it by laying the lone pair on the oxygen, come and attack that site. So it looks really messy. I'm going to go ahead and copy it and put it onto the next page for us to see. Okay, so I've redrawn what's been going on. We got most of our molecule actually finished. We just have a few things we need to finish up. So we notice that our water that we attached is actually charged, and we want to make it not charged. If you remember in the beginning of this problem, we started with acid. So when we use up that protons, there's going to be a conjugate base floating around. So I'm going to designate that as just a capital B with some electrons on it. And we should probably say that one of these hydrogens are hanging out from the oxygen. So let the conjugate base come around, pull off that proton, and give the electrons back to the oxygen. Okay, so for our purposes, we are just about done. If you remember from the first page, what our molecule looks like exactly what we have right now. It's just that we want to turn this enol into the keto form. And so we've done this several times. And so we know we can just write tautomerization above our arrow because we know the steps for that. And at this point, it's just become trivial. So tautomerizing an enol will get us into our final product. So we can draw that real quick. So I would start drawing these, by the way, with that first middle ring. followed by this ring. I'm going to add in those methyl groups so I don't forget them. Just like this. And then now there's our tautomerization in play. So that's our final product, and this is the full detailed mechanism for it.